Chapter 5 Energy, Part 3 of 3. Non-renewable energy sources. Non-renewable energy sources are those that cannot be replenished in our lifetimes. Examples include petroleum, natural gas, coal, and nuclear energy. Petroleum. Fossil fuels are appropriately named because they formed from the remains of billions of tiny plants and animals that died millions of years ago. These plants were buried under thousands of feet of sediment and sand and were turned to rock. The weight of the sediments created a lot of pressure and heat, causing the plant and animal material to undergo a chemical change. The end product is an oil-saturated rock that is much like a wet sponge. Not all organic material becomes oil when buried underground. It requires certain conditions. Refining crude oil. Crude oil is the oil that is taken directly from the ground. It is thick, black oil must be refined into usable products such as gasoline, diesel fuel, and asphalt. Oil refineries clean and separate the crude oil into gasoline and hundreds of useful products using a process called fractional distillation. Every refinery uses three basic steps: separation, conversion, and treatment. Inside the distillation tower, liquids and vapors are separated into their components, fractions, according to their weight and boiling point. The fractions with the lowest density, including gasoline and liquid petroleum gas, are vaporized and rise to the top of the tower, where they are drawn off and condensed back into liquid form. Medium density fractions, such as kerosene and diesel, stay in the middle of the distillation tower. Fractions with the highest density have the highest boiling points and settle towards the top. The conversion process uses heat and chemicals to break apart the molecules of the heavier fractions to produce more gasoline and other petroleum fuels. Treatment is the final stage of the refining process. Natural gas. Natural gas is often considered a non-renewable fuel source. Natural gas is thought to have formed after the remains of tiny sea animals and plants that died millions of years ago were exposed to extreme pressure and heat. Natural gas is a flammable combination of mostly hydrocarbon gases. Consumers of natural gas. Natural gas represents about 29% of the energy we use in the United States every year. The largest consumer of natural gas is industry, which commonly uses it as heat source to manufacture products. Residential and commercial customers and the second largest consumers of natural gas. Natural gas can be used to produce electricity. Coal, the origin of coal. Coal comes from plants and other organic matter that lived during the Pennsylvanian period millions of years ago. Plants died, fell into a swamp, and began to decay. This process continued for more than 30 million years, creating many layers of partially decayed plants. The weight of the upper layers compressed the lower layers to form peat. The peat is subjected to heat and pressure from the upper layer. Types of coal. North American coal can be classified into four categories based on carbon content and the amount of energy it can produce: anthracite, bituminous, subbituminous, and lignite. Mining the coal. The majority of coal in the U.S. is mined using either underground or surface mining techniques. Underground coal mining. Underground coal mining is used when the coal is located several hundred feet below the surface. To remove coal from these underground mines, miners ride elevators down deep mine shafts where they extract coal using continuous mining machines that cut into the walls and pulverize the coal. Coal is then loaded onto a conveyor belt and transported out of the mine. Surface coal mining. Surface coal mining is less expensive than underground mining and produces the majority of the coal in the United States. The surface mining techniques uses giant machines to remove topsoil and layers of rock to expose large beds of coal. When coal is removed and the mining is finished, the dirt and rock are returned to the pit. The topsoil is replaced and the area is replanted. The land can then be used for farming, wildlife refuge, recreation, or industry. Uses of coal. Generating electricity. Approximately 92% of the coal mined or imported in the United States is used to generate electricity. Coal-burning plants use the heat generated from the burning coal to boil water and produce steam, which rapidly expands to push its way through giant turbine blades. Industrial applications. Though the vast majority of coal is used to generate electricity, coal is also used for industrial applications. Coal contains large amounts of methanol and ethylene, as well as other ingredients that are used to make fertilizers, plastics, tar, synthetic fibers, and medicines. The paper and concrete industries also burn large amounts of coal. Steel production. Coke is a form of coal that is used in the production of steel. The coke is then removed from the oven, rapidly cooled, and shipped to a steel plant. The carbon from the coke combines with the iron to form steel. For export, the majority of U.S. coal exports go to Canada, Brazil, the Netherlands, and the UK. Nuclear energy from uranium. Nuclear fission involves splitting the nucleus of a heavy atom, such as uranium-235, into smaller nuclei. The process generates tremendous heat energy, which is used to generate steam. Nuclear fusion involves combining or fusing smaller atoms together, which also results in the release of heat energy. The sun produces heat energy using nuclear fusion. Uranium fuel cycles. A single uranium fuel pellet that is the size of a pencil eraser contains almost as much energy as 1 ton of coal. Inside the nuclear power plant. There are 2 types of power plants used in the United States: pressurized water reactors and boiling water reactors. Energy efficiency and conservation. Energy conservation simply means using less energy. The U.S. uses nearly 189 billion BTUs of energy every minute of every day of every year. The U.S. Department of Energy divides energy usage into 3 categories: residential and commercial, transportation, and industrial. Answer the following questions in your engineering notebook. What are the differences between conduction, convection, and radiation? How do we convert from one temperature scale to another? What are the 5 most common renewable energy sources and how are they used? What are the 4 non-renewable energy sources and how are they used? How do sound waves and electromagnetic waves differ? When you turn on a television, the electricity is converted into which forms of energy? Your body uses the chemical energy in food to produce which form or forms of energy? Does the United States use more renewable or non-renewable energy sources? And what is the difference between nuclear fusion and nuclear fission?